Hello everyone. So today in this channel we are going to do a little recap on the second PUC preparatory examination for Jan-Feb 2023. I'm just going to try and solve this question paper here so that those of you who are preparing for your class 12 board exams or for your pre-boards exams, you can just have a look at how these questions are to be answered, and if it's a multiple choice question or a fill in the blanks or a 2-mark question, what is going to be the approach to it, especially in terms of multiple choice when you can possibly have two answers which are almost similar to each other. How are you going to arrive at one? And in the 2-marker or 3-marker question, how are you going to get your correct answer? So those of you who are here for the first time, please do remember to subscribe to the channel and hit the bell icon so you receive notifications as and when I put any revision videos or any NCERT solutions. So let's move into the question paper. Now this is a very recent question paper that had happened a week ago. Now this one has, as per the new pattern, it has a part A in which there was multiple choice and fill in the blanks, which was not there initially. So here there are a few questions that could be confused with confusing options in it. Let's see how to do it. So here in the instructions, it clearly says that the question paper has 4 parts. All parts are compulsory. In part A, we have 20 marker and each question carries 1 mark. Now 20 marks here means 15 marks of multiple choice and 5 marks of fill in the blanks. Fill in the blanks also has some options in it, so it's easier for us to find out the answer there. Part B, as usual, is a 2-mark question, mixture of all parts in the subject. So it's an 8-mark. You need to answer only for 8 marks, which means 4 questions you need to answer. Part C is a 3-marker question. Part C is for inorganic chemistry. The part really remains the same even now. It's for inorganic only, and out of that you need to answer only for 12 marks, which means you need to answer 4 questions again. Part D is 30 marks. Each question carries 5 marks. Now in this 30 marks, some of the marks are given for physical chemistry separately, and some of the marks are given for organic chemistry separately. So basically part D is divided into part number 4 and part number 5, where part number 4 is for physical chemistry and part number 5 is for organic chemistry. Both parts are not mixed, they are separate. So totally together you need to answer for 30 marks in part D. Now it clearly says write balanced chemical equations wherever it's necessary. Some questions clearly says only chemical equations. Some questions says explain it or equations not required. So you need to see whether the question really demands it or no and accordingly write it. Draw diagrams wherever necessary. In this, in chemistry in second year, there is apart from having the diagram of SHE, the diagram of a Daniel cell, and all of these. There's not much of diagrams involved in the second year chemistry. But of course, if the question demands it, you need to draw it. So wherever necessary, you can draw the diagram only if the question specifies it. Then use log tables or simple calculators if necessary. Scientific calculators are not allowed. So there will be some questions where you have to calculate log, especially in questions like Nernst equation, in questions where you need to use log to calculate or anti-log to calculate. In those cases, the log table will be provided to you in the examination. Only simple calculators are allowed and not scientific calculators. So these are some of the rules and some of the instructions that you need to read when, especially in those exams where the paper pattern has slightly changed. Especially this year, because it's not the same as last year's options that are given. Last year we could answer very few options, but this year there are much more options in each part except for part A. Part A has always remained a part where there was no options provided at all. Alright, so here under part A, the first main is select correct option from the following choices. We have 15 questions, each question carrying 1 mark. The first question reads, to get an N-type semiconductor from silicon, it should be doped with an element with a valency of option A 2, option B 1, option C 3, and option D 5. Now whenever you see this particular one that says N-type semiconductor, N is for a negative charge. And if you need to get an N-type semiconductor, your element should have more number of electrons in the valence orbital. So here, when compared to get an N-type semiconductor from silicon, you need, because silicon belongs to group 14. right, which is the carbon family. And if you need to get a negative charge for it, you need to have electrons more than 14 or more than 4 in the valence orbital. So in that case, your only answer here is 5. Alright, because 5 meaning you're moving to the next group, which is the nitrogen family with group number 15, and valence electrons in the orbital for group 15 will be 5. So only when you dope it with a group 15 element with along with silicon, you will get n-type semiconductor. Next one is question number 2. Colligative property depends on A, nature of solute particles in the solution, B, number of solute particles in the solution, C, physical properties of a solute particle in the solution, and D, nature of solvent particles. Now by definition, when we started learning in solutions chapter colligative property, we've taught the definition of colligative property that it depends on the number of solute particles in the solution, which is nothing but option B. So colligative property is something that depends on the number of particles in the solution, number of solute particles. Then question number 3, solubility of a solid solute in liquid solvent does not depend on A, temperature, B, pressure, C, nature of solute, and D, nature of solvent. When you're looking at solubility of a solid solute in liquid, it will depend on temperature, because for example, if I'm taking a solid solute as say sugar, and if I'm taking a liquid solvent as water, I'm taking sugar and I'm dissolving it in water. Obviously, nature of the solute, which is a sugar particle, will depend on the solubility. The nature of the solvent will also depend on the solubility. Temperature also, because if I add more sugar and if it's not dissolving soon, then what do? I'm going to heat it. So temperature, nature of solute, and solvent is going to depend on solubility of that solid in liquid. But when I'm taking a solid and liquid, one property that does not really affect is pressure. So here solubility of a solid solute in liquid solvent does not depend upon pressure. So no matter how much I'm going to apply pressure, it's not going to show any difference in my solubility, because I have a solid solute and a liquid solvent. Both are not going to depend on pressure. Alright, now next question number 4. Quantity of electricity required for reduction of 1 mole of Mg2 plus ion is. Now when you get a question like this where they're asking you about quantity of electricity required when a particular ion is present, what are you going to notice? You are going to notice what is the electron count over here. What is the valency mentioned over there? That valency is nothing but the n value into Faraday's constant. Faraday's constant is clearly given to us in the option. 96,500 is given to us very clearly. Okay, so here what you will do is you will choose that particular option where Faraday's constant is given. We have two options, that is option A, 2 into 96,500 coulomb, and option B with just 96,500 coulomb. Option C and option D both are neglected because they don't come anything close to our Faraday's constant. So our option is option A and option B. Now out of these two, which one are we going to consider? Like I've told you, when you get an ion, you look at the valency. Valency, how many electrons are lost or how many electrons are gained. So there, that number into the Faraday's constant is going to give us the quantity of electricity required. Since my ionic charge here is +2, it's going to be 2 into Faraday's constant, which is option A. Alright, next is a question on chemical kinetics. Rate constant of a reaction K is equal to 2.3 into 10 to the power minus 5 liter mole inverse seconds inverse. Then the order of reaction is. So here, rather than by hearting the order of reaction and all of that, with the SI unit mentioned to us, is to know by concept how you're going to get it. Alright, I'll just show that to you so that it's easy for you to identify it. So for that, I'll just write over here on the next screen. Here, I'll write here, when you want to find out, you just take the rate formula. In general, what is the formula of rate? Concentration by time. Alright, now when you're looking at this, concentration by time, now here what you will do is, you are going to find out what is the SI unit of concentration. Obviously, it's going to be mole per liter. And time is seconds inverse. So now in this, what I'm going to do is I have to find out for each order of reaction. So here, when I'm taking for first order reaction, for example, first order, reaction if I want to take, I'm going to take rate is equal to mole per liter by seconds inverse divided by concentration, which is going to be mole per liter to the power 1. Alright, now what will happen is when I'm going to take it on the other side, this will become mole per liter by second into 1 by mole per liter, and this will become 1 over here. Now in this case, why did I take 1 over here? It is because of first order. So I'm going to take 1 here. Now what will happen? I'm going to cancel this out and cancel this out. What will I get in this case? Seconds inverse will go up and just become seconds. Alright, so it's not seconds inverse, it is seconds over here. Sorry, this is seconds. So when seconds goes up, it will become seconds inverse. So if I have this particular SI unit in my question, then it's going to be first order. So first order is cancelled out because that is not the SI unit given to us in the question. Fine, let's change this to second order. If I'm taking a second order reaction, in that case, I'll just erase this and I'm going to put a second order here. So here I'm going to put 2 and here I'm going to put 2. When I do that and when I try to cancel out the common terms, what will happen here is this entire numerator will get cancelled. 1 over here will get cancelled. 1 of it will remain in the denominator. Now when I write it, I will get mole inverse liter seconds inverse. Am I having this as the SI unit mentioned to me in the question? So here if I see, I'm having mole inverse liter seconds inverse. So this is the SI unit mentioned to me in the question here. So as per that, what was the order of reaction that I had considered? I considered a second order reaction. So this way, instead of mugging it up, it's always easy for us to work it out whenever we have a 0 first order or a second order reaction. Alright, so I hope the first 5 questions are clear to all of you. Now, let's move on to the next set, which is the 6th one. The term sorption stands for absorption, adsorption, desorption, or both absorption and adsorption. It's very clear here for both adsorption as well as absorption. Alright, next one. 7th question is on metallurgy. Zone refining process is used for the purification of aluminum, silver, germanium, copper. The only example for zone refining that we have in our textbook is germanium. Okay, next one. 8th one is on periodic table. The noble gas which does not have a general noble gas configuration of Ns2Np6 is helium, B radon, C neon, and D krypton. So here the question is very clear, which one does not have that particular electronic configuration. The smallest among all these is helium. When you look at the atomic number helium is 2. There itself it is very clear that when you write the electronic configuration of helium is just 1s2. It is not following a noble gas configuration at all because you need to have Np6 also. Whereas other elements all will have, after helium, the next one as per the periodic table given to us in this entire list is neon. Neon with an atomic number 10. So there it has 2s2, 2p6 as the valence orbital. So the one that is the least which does not have a noble gas configuration is helium. Alright, next one. Again, it's going to be from periodic table, but it moves to the DNF block. General oxidation state shown by actinoids is +2, +3, +5, and +6. This belongs to one of the characteristic features of actinoids that we're learning, that they show generally a +3 oxidation state. It comes under the general characteristics of DNF block under actinoids. Next one is in a complex ion COEN thrice +3, the oxidation state of cobalt is. Alright, now for this you need to look at this particular complex given to you with a charge +3, and you need to know what is this ligand mentioned to you here. And you have to calculate the coordination number of this particular central metal atom. You just need to know what is the coordination number over here. Alright, so here for this, I'll move to the next page and I'm just going to write over here COEN thrice and a +3. Now, if I'm trying to expand what En is, it is nothing but ethane 1,2-diamine. Alright, now if I'm trying to show this bonding to the cobalt atom, I'll just draw that. I'm just drawing a very rough figure here. Now I can show that I have NH2 here, and that's going to bond with CH2, CH2, NH2, and this. So this is one of the ethane 1,2-diamine designated as En. Like that I have 3 of it over here. So I'm going to form 3 of it over here. So I have NH2, CH2, CH2, NH2. One more I have to do for En. I have NH2, NH2, CH2, CH2, and here. So I have one En over here, one En over here, one En over here. How many of these bonds are touching cobalt? I have 1 here, 2 here, 3, 4, 5, and 6. So since there are 6 of these bonds bonding with cobalt, therefore the oxidation state over here is going to remain 6. Alright, so the oxidation state, the coordination number here is going to be 6. Next one is 11th question. CCl bond in chlorobenzene in comparison to CCl bond in chloromethane is A. Longer and weaker, B. Shorter and weaker, C. Longer and shorter, and D. Shorter and stronger. So for this we need to compare both molecules to know that. So I have chlorobenzene. So here chlorobenzene is this. This is chlorobenzene and this is chloromethane. Let's deal with this later, or not even deal with it. Let's look at this chlorobenzene here. And they're telling that this bond, what is going to be the nature of that CCl bond there? Remember one thing, whenever you look at chlorobenzene or any aromatic system, the first thing that should come in mind is resonance structure. Okay, so here since I have 3 lone pairs of electrons, these will be involved in resonance. Therefore, you will form a double bond in the center here. So because of resonance, what is happening? That bond is becoming stronger. And whenever a bond becomes stronger in your aromatic system, it is also forming a double bond there. And whenever we form a double bond, we know that the bond length will become shorter. So our answer over here has to be shorter and stronger, which is option D. Alright, that is option D. Then the 12th question. Methanol when reacted with Grignard's reagent followed by hydrolysis yields primary alcohol, tertiary alcohol, secondary alcohol, cyclopropyl alcohol. Let's try to do the reaction here. Now, methanol means CH3. Methanol is this. I have H, C double bond O, C, H. This is a methanol, which is an aldehyde group, which reacted with Grignard's reagent. They have not mentioned any specific name there, so I'm just writing a general reaction for Grignard's. Here, Grignard's R is negative. This will be positive, the remaining part. So here, R will form bond here, and the double bond will break. So when I try to form a bond, it becomes R, H, and O minus with MgX here. Further, it says in the question, it will undergo hydrolysis. So if it has to undergo hydrolysis, it has to go react with water. So here I'm going to do acid hydrolysis. Now here what happens is this O minus will pick up a hydrogen and this will form OH. The remaining part of it will form MgOHX. Alright, now here I have OH bonded to a carbon which has only one alkyl group, or OH bonded to a carbon that has 2 hydrogen. So the nature of this particular alcohol should be a primary alcohol. So here when I am ticking the answer, it has to be on primary alcohol. Alright. Now, 13th question is, toluene reacts with chromyl chloride to form a complex which on hydrolysis gives benzaldehyde. The name of the reaction is. So here it's not going to be a Friedel-Crafts reaction for sure, because Friedel-Crafts reaction you need anhydrous AlCl3. We don't have that in the question. So Friedel-Crafts reaction is ruled out. Next is Gatterman-Koch reaction. You need CO, HCl and all of that, but that's also ruled out. In Stephen's reduction, it's going to be with formation of benzaldehyde, but there you're needing a very different reagent. The only reaction where toluene as a starting material can only be an Itard's reaction. Alright, so Itard's reaction is the only reaction where toluene is the starting material to produce benzaldehyde. Okay, so that is question number 6 to 13. Let's move on to 14th question. Which of the following on heating with chloroform and alcoholic potash forms phenyl isocyanide? Now here this is very easy. You need to form phenyl isocyanide. The only reaction where we learn isocyanide formation is using aniline. Alright, that is your carbylamine test, where you use a primary amine, you react with chloroform and alcoholic potash, and then you form a phenyl isocyanide. 15th question is nitrogen base that is not present in DNA is. So it's a very common question. Out of all these options, uracil is not present in DNA. Alright, so this way some of the multiple choice questions need to be worked out to get correct answers. Some of it you already know it by heart. Now in part 8 of second main, fill in the blanks by choosing appropriate word from those given the bracket. 5 mark. Each question carries 1 mark. The options are very, very visible when you look at the questions here. Alright. So here the value of Henry's constant Kh increases with increase in. The only option that is here is temperature. Alright. So here your option here, I'll just write the question number. This is for the answer for 16th one. So the value of Henry's constant increases with increase in temperature. Next one. Role of a catalyst in a reaction is to change. When you look at catalyst and all of that, it takes you to the chapter which is chemical kinetics. So the only answer here is activation energy, which is 17th one. Next one, the gas liberated when zinc reacts with dilute HNO3. The only gas that is there among all this is N2O. So that is your 18th answer. Then the major product formed when 2-bromopentane is heated with alcoholic potash is. The next answer is pent-2-ene. It's a very direct answer. The last one is dash acts as an anti-fertility drug. It is here, the last one. It is norethindrone. So this way your fill in the blanks are also very easy. So next is from part B. Now part B is a combination of all inorganic, physical and organic chemistry. Now here we are given with these questions carrying 2 marks. So you need to answer any 4 out of the following. Alright. So the 21st question is, what is Frenkel defect? What is its effect on density of a solid? So 1 mark is for the definition and 1 mark for the effect of density on solid. So here we can write that the displacement of cation from its normal position to an interstitial site is called Frenkel defect. Alright. So here basically in a Frenkel defect, if you're taking a cation, alright, it's a cation that will go from its own position to an interstitial site. Such kind of a defect is what is called as a Frenkel defect. So that carries 1 mark. Alright. So this one definition here will give you 1 mark. Now after this you have one more question. What is the effect of density on the density of a solid? Because it's just a replacement of a cation from its normal site to the interstitial site, there won't be much difference in the density. So you can write that the density of the crystal does not change. Alright, so this one will carry 1 more mark. Alright, so this is a 2-mark question. Now, next question is question number 22. Here it says draw a neat label diagram of H2O2 fuel cell and write overall cell reaction. Again 2 marks, 1 mark for a neat label diagram and 1 mark for the overall cell reaction. So here if you're drawing this, you have to draw your diagram. I'm just drawing a very rough diagram over here, so it may not really come properly. So here I have my fuel cell. Alright, that's my anode here and the cathode over here. Alright, so this is the diagram. Now you're going to label it. So we have an inlet to oxygen gas. We have an inlet to hydrogen gas. This is going to be the anode. This is the cathode. From here goes out is water. And this one here is going to be aqueous NaOH. So this is the entire diagram of fuel cell. Now this diagram is going to fetch you 1 mark. Alright, the other 1 mark is for the overall cell reaction. So you can write that the overall cell reaction is, here you're trying to produce water. So let's write the reaction. We have H2, which is gas, plus O2, which is also gas, will produce H2O, which is liquid. Go ahead and balance the equation. 2 over here and 2 over here. This balanced chemical equation is going to give you 1 mark. So it's a 2-mark question. Alright. Now, next question is question number 23. It is a problem from chemical kinetics. A first order reaction is found to have a rate constant K. This K is not this K, it has to be small k. Okay, so small k is equal to 5.5 into 10 to the power minus 14 seconds inverse. Find the half-life of a reaction. Half-life of the reaction you need to find out. So because it's a first order reaction, half-life formula is going to be 0.693 by K. It's a 2-mark question, so your 1 mark is going to go for the formula. Now, after this, you just have to substitute the value 0.693 by 5.5 into 10 to the power minus 14 seconds inverse. 0.693 by 5.5 is going to give you 0.126 into 10 to the power minus 14. When it goes up, it becomes plus 14. Seconds inverse, when it goes up, it becomes seconds. Now, just to give that significant figure, we shift 1 decimal to the right. That will be 1.26 10 to the power. Because you've shifted to the right, your number here will reduce. It will become 10 to the power 13 seconds. This final answer with the unit will fetch you 1 more mark. So 1 mark for the formula, 1 mark for the final answer with correct unit. Okay. Now, next question is question number 24. Give reason. Okay. So first one, this is coming from D and F block. Here it says zirconium and hafnium have almost identical radii. The minute you come across zirconium and hafnium in the entire chapter of D and F block, there's only one place that you learn about zirconium and hafnium, and that is in lanthanoid contraction. So one of the reasons as to why zirconium and hafnium has identical radii, it's because of lanthanoid contraction. So here you will write this is due to a lanthanoid contraction. That's your first answer. Now, second answer is Sc3 plus ions are colorless. Now, wherever we say it is colorless, it's probably because they don't have an unpaired electron. Alright, but sometimes in exam, say for example, you kind of forgot what is the answer to it. So what you would do is you can try and work out this. Okay, so I'm having Sc, scandium. Okay, so scandium is nothing but atomic number 21, the first in the 3D series. So for this, I'm trying to write the electronic configuration. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Alright, now what will happen is when I want to form a Sc3 plus ion, which means I need to remove 3 electrons from the element. So the last orbitals in which the electron entered is these two. So first the electron will move out from the 4s orbital, then it will move out from the 3d orbital. So first let's take it out from the 4s orbital. 4s has 2 electrons, so that will become 1s2, 2s2, 2p6, 3s2, 3p6. This is be 4s0 it will become, because 2 electrons will move out and you need to form 3 plus. So one more will move out from the 3d orbital. So it will become 3d0 also. Now if you see, all these are filled up. They don't have any unpaired electrons. Therefore, this one is due to the absence of unpaired electron. Alright, so if you don't remember the reason, you can probably work it out and find out what is the reason. So if a particular ion is colored and the other one is colorless, it's colored because of the presence of an paired electron, of an unpaired electron. And if it's colorless, it's because of the presence of, it's due to the absence of the unpaired electron. Alright, so it's just 1 mark. So 1 mark here and 1 mark here. You don't have to work it out. You just have to write the final reason to it. Okay. Now, next question. 25th question. How is phenol prepared from cumene? Write equations. So here it clearly says write equations and you need to explain how it is. Okay. So here you have to write down. First, we'll write down the equation, then go ahead and write the explanation to it. Becomes easier for you. So you can write down cumene is this, where you have a benzene ring and you have a propane chain where the second carbon is bonded to benzene. This is cumene. Alright, so cumene is treated with oxygen. Now what will happen is all these carbons on it will be placed like this. Okay, now that center carbon, the hydrogen is going to be placed elsewhere. This oxygen will be here. Okay, and the hydrogen that was bonded over here on this carbon will now be placed here. So what has happened is this is just going to move to the last. That carbon hydrogen that was there goes to the last. This linkage over here is a peroxide linkage. So you can write your compound name as cumene hydroperoxide. Now this further will undergo acid hydrolysis and you will form this entire compound that will come out as CH3, C double bond O and a CH3. So what have you formed here? Acetone is the byproduct. Okay, this OH that is here will bond directly to the benzene ring and it will form the product that we want, which is phenol. Alright, so this is a compulsory question. It will be there in the PUC, the second PUC paper from phenols. Please don't skip out to read it. Now this entire equation that you wrote here will fetch you 1 mark. Where is the other 1 mark? In the explanation. So same thing, whatever you wrote in words, you can just write it here, that cumene reacts with, either you can write reacts with or oxidized, you can write, reacts with oxygen to form cumene hydroperoxide, which further undergoes acid hydrolysis to form phenol. This sentence will give you 1 mark. So it's a 2 mark question. Alright. Now, next one is question number 26. Again from your organic chemistry chapter, but this is from aldehydes ketones. So here, write the reaction equation for the reaction between benzaldehyde and concentrated NaOH and name the reaction. So there are 2 questions here. One, you just have to write the equation. Second one, you need to name what that reaction is. So let's write the reaction. Here we have benzaldehyde as our reactant. Okay, and this is going to be treated with NaOH, which is concentrated. Now, In the entire aldehydes ketones chapter, there's only one reaction where concentrated NaOH is given, and there's a clue here. It is a name reaction. That's why the second question is name the reaction. So that means of the name reactions that you learned under aldehydes ketones, there's only one reaction where concentrated NaOH is used, and that name of the reaction is what? It is Cannizzaro reaction. Okay, it's nothing but it is Cannizzaro reaction. So in Cannizzaro reaction, you need two of this. Okay, you need two of that reacting with concentrated NaOH. In one of it, you're going to form sodium salt of carboxylic acid, the benzoic acid, and the other one is going to give you benzyl alcohol. So what are you forming? You have benzaldehyde. Alright. You have sodium benzoate and you have benzyl alcohol. Alright. So this equation will carry 1 mark and the name of the reaction will carry 1 mark. Okay. Next one. 27th question, what is the role of these food additives? Okay, so first one, saccharin, it's going to be an artificial sweetener. And the second one, sodium benzoate, is going to be a food preservative. It's going to be a food preservative, each carrying 1 mark. Next one is from the last chapter, which is chemistry in everyday life. Here it is, what are anionic detergents, and give an example. So here you can write the definition that they are sodium salts of sulfonated long chain alcohols or hydrocarbons. That is your entire definition for this. These are the keywords: sodium salt of sulfonated long chain alcohols or hydrocarbons. That's a keyword. It has to be there in the definition. And the example for this is going to be sodium lauryl sulfate. So 1 mark for the definition, 1 mark for the example. Alright, so that is with part B, where we had around 8 questions and you're supposed to answer any 4. It is a mixture of organic and inorganic and physical chemistry questions. Alright, now let's move on to the next part, which is part C. Okay, now in part C, you are going to have 3 mark questions. Okay, part C you're going to have 3 mark questions, and part C is all about inorganic chemistry. So you will have your questions from metallurgy, you will have questions from periodic table chapters, P block, D and F block, coordination compounds. These are the chapters from which you can be asked questions in part C. Alright, and they're all 3 mark questions. Now first question is from metallurgy. Draw a neat label diagram of an electrolytic cell used in extraction of aluminum by Hall-Herold's process and write the reactions taking place at cathode and anode. So you need to draw a very neat label diagram. I'll just roughly draw the diagram. I'm not doing any sort of shading here. The detailed diagram is there in your textbook already. Okay, so I'll just draw the steel tank with an outlet. Alright, now I have just putting a lining over here for the steel tank, and okay, I'm going to have inside, just going to place these, okay, and this one here, just naming them as molten Al. Here I'm going to have molten Al outlet. This is going to be pure alumina plus cryolite. These things are connected together to a battery, which is a positive terminal. This is further connected and this is the negative terminal. These rods that you see here are the graphite anodes. This center part that you see is nothing but carbon lining, which is the cathode, and this here is the steel tank. Very rough diagram. The entire detailed one is in your textbook, so please follow that. Now another thing is write reactions that are taking place at cathode and anode. So at cathode, the reaction that will take place here is Al3 plus 3 electrons giving Al liquid, that is a molten one. And at anode, what will take place, you need to write both reactions where carbon, which is in the solid state, reacts with O2 minus to form carbon monoxide gas and 2 electrons. Then further, that carbon is going to react with 2 oxygen, O minus oxide, to form O2, CO2 and in the gaseous form plus 4 electron. So here the entire diagram is going to give you 1 mark, cathode is going to give you 1 mark, and anode will give you 1 more mark. Alright, so it's a 3 mark question. Okay, now next is question number 30. For the manufacture of nitric acid by Oswald's process, write equations with conditions. Here it only says equations, so just write equations with the conditions. Alright, so here we have 3 steps. So step 1 is oxidation of ammonia to nitric oxide. Alright, so step 1, that is, so here we can write 4 of NH3, which is gas, plus 5 O2, which is also gas, now in the presence of platinum and rhodium gauge at 500 Kelvin and 9 bar pressure will form 4 of nitric oxide plus 6H2O. Balancing is very important. So if you're not a person who kind of know balancing, please try to learn them. I will also make a video on balancing very soon so that you know how to do it. Then step 2 is oxidation of NO to NO2. Alright, so here we can write 2NO, which is in the gaseous form, plus O2, which is in the gaseous form, will give 2NO2, which is again in the gaseous form. And the last step, that is step 3, will be formation of nitric acid. So here what you do is you're going to treat your NO2 plus water, which will give HNO3, which is in the aqueous form, plus NO, which is in the gaseous form. So each step here will carry 1 mark, provided the balancing is correct and the conditions are correctly written. Alright. Next is a question from P block. Here, complete the following reactions and 3 reactions are given. So for the first one, SO2 plus Cl2 in the presence of charcoal, your answer for the first one is SO2Cl2. Okay. Second one, NO plus O3 is going to give you NO2 plus O2. And the third one is from an interhalogen compound Cl2 plus excess of F2 will give 2ClF3. Wherever balancing is required, you have to balance your equations. Alright, now next one is question 32. It has 2 parts, so it's 2 plus 1 in the division of marks. Mention any two reasons for anomalous behavior of oxygen. We have so many reasons. We have oxygen is small in size, there is high ionization enthalpy, high electronegativity, absence of d orbitals in the valence orbital. Any of the two reasons you can write for this question. So first one I can write, say, small size. Alright. Then I can write high ionization enthalpy. Then I can write high electronegativity. Then I can write non-availability of d orbitals in the valence shell. Any 2 points will give you 2 marks. Then question number B, write the structure of sulfuric acid. Very simple one. Sulfur will be placed in the center, double bond O on top, double bond O here, OH and OH. H2 are there, SO4 are there. You have 2 oxygens with replaceable hydrogen atom. Okay, so that is going to be the structure of H2SO4. Next one, question number 33, write balanced equations involved in the preparation of potassium dichromate from chromite ore. Again, a compulsory question in the PUC board exam. So here you can write that when you're writing, they only says write balanced equation. So you can just write the balanced equation. Here we can write 4FeCr2O4 plus 8Na2CO3 plus 7O2 will give 8Na2CrO4 plus 2Fe2O3 plus 8CO2. That's your first step. Now this sodium chromate here will react with acid. Alright, so it will be treated with H plus to form Na2Cr2O7 plus 2Na plus H2O. Now this sodium dichromate will react with KCl to form K2Cr2O7 plus 2NaCl. It's a 3-mark question. So each equation with proper balancing will give you 3 marks. Alright, so that is your answer for the question number 33. Next is question number 34. It is a 3-marker, so each question carrying 1 mark. Which element in the 3D series exhibits maximum number of oxidation state? Your answer is Mn, manganese. What are interstitial compounds? So here you can write the proper definition. Here you have to write that the compounds in which small non-metallic, okay, it will be very specific in the definition, in which small non-metal atoms like hydrogen, carbon, nitrogen or boron are trapped into the interstitial sites of transition metals are called interstitial compounds. Alright, now question number C, write spin-only formula to calculate magnetic moment. You just have to write the formula. Magnetic moment is equal to N into N plus 2 Bohr's magneton. Each of this question carry 1 mark. Alright. Now, next question is a question on VBT. It will be a compulsory question. As per our syllabus, we have 4 VBT molecules. Any one will be asked for the exam. So here, your complex here is NiCN4 2 minus. Ni, its atomic number is given as 28. What are you supposed to calculate? You need to find out hybridization, geometrical structure and magnetic property. Very easy one. So here you're given with your atomic number 28. When you write the electronic configuration, you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. So in the ground state, it is 4s2, 3d8. you need to find out what is the oxidation number of Ni in this particular compound. So when I take X as Ni plus Cn is going to have a -1 charge. How many Cn are there? It is 4, and this is -2. So when I calculate, X will get, Ni will get +2. So if I want to move from Ni to Ni2 plus, when I try to draw the orbitals here, draw the 3D, then I draw the 4s. So first I'll draw the ground state, that is in Ni. When I draw that, I'll get 1, 2, 3, 4, 5, 6, 7, 8. And 4s, it's going to be 4s2. So this is the ground state where I have 3d8 and 4s2. Now oxidation state is +2, so let me move to the +2 state. When I move to the +2 state and draw my orbitals here, let's see what changes do I get. When I have to remove the orbital, the electrons from the orbital, it will first go from the one that has the highest quantum number. The one that has the highest quantum number is 4s. So if I have to form 2 plus state, 2 electrons should move from the 4s orbital. Therefore, it will become 4s0. 3d remains untouched, so it remains the same. 3, 4, 5, 6, 7, 8. So now that I know what is the oxidation state of Ni and I've arranged the electrons accordingly, I need to check the effect of a ligand on that particular metal. So you should write here, since Cn minus is a strong ligand, it causes the pairing of electrons. So what will happen? Whatever electrons you have in the 3d orbital will get paired up. So when I try to do that, and when I draw the orbital here, I will get, this will remain as 4s0, 1, these all are paired, but this here will move over here and pair up. That is the effect of ligand. This will still remain as 3d8. Now to show hybridization, I'm going to separate the electrons that are there in the metal, and I'm going to separate the electrons coming from the ligand. So when I separate them, okay, these are the electrons from the metal that I just paired up. Okay, these are the electrons from here. Now starting from d orbital, how many vacant orbitals do I have? Only 2. That is this orbital and this orbital. But how many ligands are there? I have 4. So I need 2 more. Where will I get that 2 more? When I get it from 4p orbital, I can get 2 more. So when I draw that over here to show the hybridization, this is coming from 3d. This is coming from 4s. The remaining 2 both are coming from 4p. So therefore I can write here that the hybridization is going to be dsp2. Now each ligand is going to donate a pair of electrons. So I'm going to put first Cn over here, second Cn here, third Cn has donated 2 electrons, and fourth Cn has donated. So each ligand is going to donate a pair of electron, and therefore they are filled. Now when you have dsp2, the geometry here is going to be square planar. Alright, and what about the magnetic property? If I'm looking at the magnetic property, I'm going to check only in these orbitals where the metals are there. Metal electrons, all are paired electrons, therefore they are diamagnetic. There's no point in seeing the electrons that have come from the ligand from these boxes. There's no point in seeing, because always each ligand is going to donate 2 electrons. Therefore, every time it's going to remain paired only. What you have to check is the ones that are there in the metal side. Okay, so you calculate the entire thing, then you get the 3 marks. If you write only this, probably 1 mark only you will get. You have to show the ground state, the excited state. You have to show the effect of ligand, what is happening, and all of that. Only then you get that entire 3 marks. Alright, now last question under part C, that is again from coordination compound. What is an ambidentate ligand, and name the type of structural isomerism that arises when such a ligand is present in the complex. So for this we can write that a molecule or an ion which contains 2 donor atoms but only one of them forms a coordinate bond at a time with the central metal atom. So here if I take an example of CN, there can be a nucleophilic center at carbon, there can also be at nitrogen, but only one will start bonding at a time, right? So that is basically ambidentated nucleophile and or a ligand. Now, if you're looking where this kind of ligands can form which kind of a structural isomerism, for that you can write it is going to be a linkage isomerism. So that's a 2-mark question. 1 mark for linkage isomerism, 1 mark for the definition. B part is write the IUPAC naming of that particular compound. Now here, since it is going to be a compound where Cl2 is outside, you're going to start naming the ligands first in alphabetical order. So here I'm going to write tetraamine with the double M, tetraamine, aqua, chlorido, cobalt. When you calculate the oxidation state of this, so if I'm taking oxidation state of cobalt as X plus, ammonia and water both are molecules, so they will remain 0. Chloride here is -1, plus there are 2 chlorides outside, so that will become -2, which is now equal to 0. When I calculate this, X is going to be equal to 3. So I will get 3 over here. 3, and the last outside bracket will give chloride. All this you get it right along with the state and along with the oxidation number correctly and writing the name properly, then you get that 1 mark for this particular name. Okay, so like this, from part C, you need to answer any 4 as per the new pattern, which is entirely inorganic chemistry only. Alright? Alright, so the next question is from part D. Now in part D, the questions that are asked are from physical chemistry. So here we are supposed to answer any 3 questions. Alright, so this is a 5-mark question where the questions are either divided as 4 plus 2 or 3 plus 5, 3 plus 2 division. So here 37th question is from the chapter solid state. A part, which is calculate the packing efficiency in a face-centered cubic lattice. So this 37A part could be any one packing efficiency question asking you to derive the entire packing efficiency. So here what you will have to do is for the A part, you need to do the entire derivation of packing efficiency, starting from writing the formula of a packing efficiency. Alright, so formula of packing efficiency is given here. It says volume occupied by 4 atom. 4 atom because number of atoms per unit cell in FCC is 4. Divided by total volume of the Q of the unit cell into 100. Now, you need to draw the diagram, whether it's BCC, FCC, whatever, you need to draw its respective diagram. Then do the calculation. So each atom is considered as one sphere. So we have one sphere here. Each of these spheres are considered as atom. Therefore, the volume of all 4 spheres is what? 4 into 4 by 3 pi r cube. Volume of one sphere is 4 by 3 pi r cube. But because this is an FCC, 4 atoms are there. Therefore, 4 into 4 by 3 pi r cube. That becomes 16 by 3 into pi r cube. Now, let A be the edge length of the cube. So if you're considering one edge of this, A is going to be one of the edge length and R is going to be the radius of the sphere that is there over here. So here when you look at the radius, you have one radius over here, you have one radius here, one radius here and one radius here. So the entire line here has 4 radius. Therefore, the face diagonal AC, this is AC. So this entire diagonal is 4R because there are 4 radius on it. So now what you'll do, you will calculate the Pythagoras theorem for it. Simple thing, AC square is equal to BC square plus AB square. AC square is taken as B, that is a diagonal. So B square is equal to A square plus A square. This will become B square is equal to 2A square. Therefore, B is equal to root of 2A. But we can say that B is equal to 4R. Right? That's what we just calculated here, that B is equal to 4R. Therefore, instead of B, you can write 4R over here. So, from this, you can get the A value. So, A is equal to 4R by root 2. When we further calculate this, it will become 2 root 2R. So, now we know what is the total volume of the unit cell. You know what is the volume of the 4 atom sphere. You're going to just substitute it in the formula here. So here when you substitute it, it will become 16 by 3 pi r cube divided by 2 root 2 r cube. into 100. Now when you just simplify this, your percentage for FCC is going to come up to 74%. Alright, so that is the answer for the packing efficiency. Now in the next one, you are going to have a problem based on density. The question reads, lithium metal has a body-centered cube, so this is important, BCC, with an edge length of unit cell 352 picometer. Calculate the density of the lithium metal given that the atomic mass of lithium is 7 gram per mole and the Avogadro's number is 6.022 10 to the power 23. It's a 2-mark question. Let's see how to solve it. So in this question, what is given to us? Alright, first we'll write down the formula that density is equal to Z into M by A cube into Na. Now, what is given to us in the problem? The question clearly says it is BCC, so for BCC, Z value is 2. The M value, that is the atomic mass, is going to be 7 gram per mole. Then A value here is 352 picometer, which when converted you get 352 10 to the power minus 10 meters. Alright, and last one is Na value, which is A is 6.022 into 10 to the power 23. All values are given, you just have to substitute it here. So Z value is 2, so 2 into 7 by 352 into 10 to the power minus 10. It is A cube, so you're going to cube the entire thing. Into Na value is 6.022 10 to the power 23. Now when we simplify this entire thing, your answer is going to be 0.533 gram per centimeter cube. Alright, so this is going to be the answer. Just make one correction that this is centimeter and not meter. Alright, so this is going to be the answer for the density problem. Now, next question is based on solutions chapter. Here it clearly says, on dissolving 2.34 gram of a solute in 40 grams of benzene, the boiling point of the solution was higher than that of benzene by 0.81 Kelvin. Kb for benzene is 2.53 Kelvin kilogram per mole. Calculate the molar mass of the solute. So here it is a problem on elevation in boiling point. So let's see first the formula. So for the A part, I'm just writing the formula that MB is equal to KB into WB into 1000 by delta TB into WA. Alright, now here you need to know what is WA. WA is for solvent and WB is for solute. So we have to first put the values given to us. So here it says on dissolving 2.34 grams of solute, and solute is WB, so WB is going to be 2.34 grams. Then in 40 grams of benzene, so that's going to be WA, which is 40 grams. Then the boiling point solution was higher than that of benzene by 0.81 Kelvin. So here you're going to write that boiling point of benzene is going to be that much. So therefore that is going to be the temperature. Temperature is 0.81 Kelvin. Next one, the Kb value is equal to 2.53 into 10 to the 2.53 Kelvin kilogram per mole. You need to calculate what is the molar mass. Let's just substitute the values. So Kb is 2.53, then Wb is going to be 2.34 into 1000 divided by delta Tb is 0.81 into Wa is going to be 40. Now when we try to solve this, the final answer will come up to 182.72 gram per mole. Alright, so it's a 3-mark question. 1 mark will go for formula, 1 mark will go for substitution, 1 mark will go for final answer with correct unit. Now the second question is mention 2 differences between ideal and non-ideal solution. You have enough differences, any 2 you can write. Let's see what the differences are. So I'll put ideal on one side and on the other side I'm going to put non-ideal. Alright. Now Let's see differences. The first one is of course very obvious. It obeys Raoult's law at all ranges of concentration and temperature. Alright, on the other side it's opposite. They do not obey Raoult's law at all range of concentration and temperature. Alright, so that is A. Then the second one, the energy required for the volume mix is 0 in case of ideal solution, whereas this is not equal to 0 in case of non-ideal. Third one, you can same way write with respect to enthalpy. This is also equal to 0, but here it's not equal to 0. Third one, you can talk about the force of attraction. You can say that the force of attraction between A and B molecule will be same as that of AA and BB molecule. On the other side, it is going to be either greater or lesser. So this way you have so many values, so many points that you can actually put out when you're talking about ideal, non-ideal solution. Since it's a 2-mark question, any 2 points are more than enough. Alright, now next question is a question on electrochemistry. Calculate the EMF of the cell in which the following reaction takes place. Here nickel and silver solution is given, concentrations are given right below it, E0 value is also given. You just have to calculate what is E cell. So here we can write that E cell is equal to E0 cell minus 0.059 by N log of Ni2 plus divided by Ag plus the whole square you have to write as per the balanced equation. Now let's substitute the values. E0 cell is how much? Here it's given as 1.05 volt minus 0.059 by N. N is the number of electrons, so that's going to be 2. Log of concentration of Ni2 plus is going to be 0.160 divided by, for Ag it's going to be 0.02 the whole square. Now when we simplify this, you will get 0.05 minus 0.0059 by 2, you will get 0.02955 log of, when you square this up and divide it, you will get log of 4 into 10 to the power 4. Alright, now when you simplify this further, your final, after finding out log and all, your final answer is going to be 0.914 volt. So you calculate log, you multiply it, and then when you minus it, you will get 0.914 volt as your answer. Alright, next question is what are secondary cells or batteries? Given example. So 1 mark for the definition, 1 mark for the example. Alright, so let's see what you're going to write for this. So for the definition of this, you can say the batteries which can be recharged by passing current in opposite direction are called secondary batteries. Alright, if you're giving an example, you can give an example of, say, a lead storage battery. Okay, or you can give nickel cadmium cell. Any one you can give as an example. Alright, so that is with that question based on electrochemistry. So the next question is based on chemical kinetics. 40th question. A part is derivation of an integrated rate equation for a rate constant of a 0 order reaction. So you need to do the entire derivation. So for that, here you're going to do is consider, since you're doing for a 0 order reaction, you're going to write consider a zero order reaction. So you're going to take R giving products. Now here you can say according to rate law. Alright, according to rate law, a rate is equal to K R to the power 0. This is because it is a zero order reaction. Therefore, we can say that a rate is equal to K, because anything to the power 0 is 1. Okay. Now, therefore, we can say that a rate is equal to minus of dr by dt, which is by definition. Alright. But we can say that since rate is given here like this, instead of rate, I can put this entire thing. Alright. So, I can say therefore, minus of dr by dt is equal to K. Now what you're going to do is going to rearrange the entire equation. All that you're going to do is cross multiply it. When you cross multiply, you will get minus of dr, which is equal to K dt. Now what you're going to do is you're going to integrate the above equation. When you do that, you will get dr is equal to minus K and dt. Alright, now when you simplify this, you will get R is equal to minus KT plus I. Now I is called as an integration constant. So now what you will do is, you're going to consider that when T is equal to 0 and R is equal to R0, which is the initial concentration and initial time. When you substitute it back in the previous equation, you will get R0 is equal to minus K into 0 plus I. 0 into anything is 0, so therefore R0 is equal to I. Substitute this R0 is equal to I in this equation, and therefore you will get here R0, R is equal to minus KT plus R0. Alright, now what you will do is take out the K value and you will get R0 minus R divided by T. That is going to be the final equation for your derivation. Alright, so that is the 3-mark derivation. Now, next one is name any two factors that affect the rate of a reaction. So, for this you can write the first factor is nature of a reactance. Then B, temperature. C, concentration of a reactance. And D, catalyst. Alright, so these are some of the factors affecting rate of a reaction. Alright, now next one is 41st question. Here it says, it's from surface chemistry. What is homogeneous catalysis? Give an example. So here we can write that a reaction in which the reactants and catalyst are in the same phase is called homogeneous catalysis. Alright, so you need to have your reactants and your catalyst both in the same phase. When they have asked you an example, you can give an example here. 2SO2, which is in the gas phase, plus oxygen in the gas phase, which will give SO3, that is also in the gas phase. Balance your equation. Now the catalyst used here is NO, which is also in the gas phase. So 1 mark is for the reaction, 1 mark is for the catalyst. Alright, now same question, B part. Name the phenomenon or the effect for the following. Colloidal particles in a zigzag motion. For this the answer is going to be Brownian movement. Alright, Brownian movement. Then C, scattering of light by colloidal particles, your answer is going to be Tyndall effect. Alright, so each of them carrying 1 mark. Now, C part of the same question, give an example of an oil dispersed in water type emulsion. You can give milk, you can give vanishing cream, and all of that. Alright, so there's a table for this in NCERT which you can go through. There, each of these classifications of colloids based on their physical, based on what is the dispersed and dispersion medium. Examples, two examples are given. Any one example you are expected to learn. Alright. So that is with your physical chemistry, where the question numbers are from 31 to 37 to 41. You have to choose any 3. The next set of questions that we're going to write is for organic chemistry. So it's going to start from question number 42. We have to answer any 3. Now, 42nd question is from haloalkanes and haloarenes. The first one is, write equations for steps in SN1 mechanism of a tertiary butyl bromide into tertiary butyl alcohol. Here it only says write the mechanism, so we don't really have to look into anything else. 2 mark question, 2 steps carrying 2 marks. So here you can write step 1, which is formation of carbocation. So here you can write tertiary butyl bromide is the molecule given to us in the question. So we can clearly use tertiary butyl bromide. Okay, for this you can write over here that it's a slow reaction and it's a rate determining step, and then you can show that the arrow moves towards Br, therefore forming your stable carbocation. Alright, so you form plus charge plus Br minus. Then after this you can write the step 2, which is attack of nucleophile. So you can have here attack of nucleophile. Take the carbocation that you have. Okay, and your nucleophile here is OH minus because you need to form an alcohol. So here you can form your tertiary butyl alcohol. You can show the arrow moving towards the carbocation. Then the second part of this is explain Wurtz-Wittig reaction with an example. Again a 2 mark question. So for that Wurtz-Wittig reaction, if you want to explain, you can first write the reaction. So for Wurtz-Wittig reaction, one of the R group has to be a benzene ring and the other R group can be a alkyl group. This will react with sodium in dry ether. So here what will happen is both the chlorine atoms will go to Na and form NaCl. The methyl group will go to benzene ring and it will form CH3 here. Alright, so that is your equation. Equation will carry 1 mark. For this you need to write a line of explanation that says, you can write here that chlorobenzene reacts with methyl chloride with sodium in dry ether to form toluene. This compound name that is there over here is toluene. So that will carry 1 mark. The equation will carry 1 mark. Now, question number C is what is a chiral carbon? You can write a carbon atom which is bonded to 4 different groups or atom is called a chiral carbon. Okay, so this one definition will also carry 1 mark. Alright, now next question is on alcohols, phenols, ether. 43rd question. A part says explain the mechanism of acid catalyzed dehydration of ethanol to ethene. So here also you have step 1, which is protonation of alcohol. Alright, So here you take your alcohol, which is ethanol given to you in the question. So I have ethanol here. That is going to react with acid. So what happens is the lone pairs on oxygen is going to pick up hydrogen, have H plus, to form OH2 with a positive charge. Then after that, the step 2 is going to be removal of water molecule. So here you take that same compound and you are going to remove that water molecule, therefore forming a carbocation. And then the last step is going to be removal of H plus. So here I'm just going to split that particular molecule, H and H, H and H with a positive charge, and from the adjacent carbon it's going to form a double bond. So you will get CH2 double bond CH2. Each step will carry 1 mark. Now second question is for the preparation of ether by Williamson's ether synthesis, write the general equation. So for this general equation for Williamson's ether synthesis is RONA plus R dash with an X. This one will give RONA will break over here and you will break your compound in such a way that your compound will break here and will form ROR dash plus NaX. That is the general equation. Then C is, the question clearly says that what is the effect of electron withdrawing group on acidity of phenol. So I'll make you understand here. Let's say if I'm having phenol, alright, what happens here during resonance, the lone pairs on oxygen will go towards the carbon atom, go towards the benzene ring, therefore making this particular group more acidic in nature. Now what will happen is if I'm adding an NO2 group here, what will happen? That pulling of the electrons into the benzene ring becomes more because this group here is an electron withdrawing group. So the effect will be more, making it more acidic. Therefore you can write that in the presence of electron withdrawing group, the acidity increases. Alright, so these questions will carry 1 mark. Okay, now next question is 44th question. A part, explain Rosenman reduction of benzoyl chloride. Okay, so here you can write that taking a benzoyl chloride plus H2 and palladium with barium sulfate. Now what happens here is basic reduction reaction. Cl will move out and hydrogen will replace there. So here C double bond O H plus HCl. So this will give 1 mark. Below this you can write that when benzoyl chloride reacts with hydrogen in palladium and barium sulfate, benzaldehyde is formed. So 1 mark for the explanation and 1 mark for the equation. Second one is, how is benzamide obtained from benzoic acid? So I'm going to write here, I have benzoic acid that's going to be treated with ammonia and this will form amide. Okay, so it's going to give C double bond O and NH2. Alright, now this further here once you form the benzamide, 1 mark is for this and the other mark is for a sentence. So you can write benzoic acid reacts with ammonia to form benzamide. In between this there's also a step where you are trying to form the the ammonium compound of it. You can write that also, ammonium benzoate. That can also form as an intermediate there. Alright, now question number C, name the reagent used in Clemenson's reduction. Here you should write zinc amalgam in concentrated HCl. That will give you 1 mark. Alright, now next question. Question number 45. Explain Hoffman bromamide degradation reaction for the preparation of methylamine. Alright, so A part here is to write the equation. So I have here acetamide with NaOH and Br2 at a particular temperature to form methenamine plus sodium carbonate plus sodium bromide plus water. Now what you have to do is you need to balance it. So you have to put 4 over here. Then you have to put 2 in front of NaBr and 2 in front of water. Alright. So 1 mark will go for this entire equation. 1 more mark is to explain the entire equation in words. So you can write acetamide reacts with NaOH and Br2 to form methylamine. Alright. Next question is for how does aniline reacts with bromine water at room temperature, give equation. So you write down that aniline NH2 reacting with Br2 and water. So you need 3 of this and you're going to form NH2 with a Br and a Br plus 3 HBr. Alright, so same thing, you can write this in terms of words also. That will give you 1 more mark. So you should write here tribromoaniline. So same thing you have to write in sentences, that aniline reacts with bromine in water to form 2,4,6-tribromoaniline. Alright, now the C part of it, that is a IUPAC naming for it. For that the compound here can be written as, here you have ethyl chain as the longest chain and methyl chain which is the smaller chain. So definitely your naming can be N-methyl ethanamide. Okay, so that is going to be the answer for this particular question. Alright, now next question is question number 46. Write Habot structure for maltose. You have to write a very correct structure for it, draw it properly, only then you will get your marks. Let's draw that. So just put all these bonds correctly. Alright, now I'm going to write it with hydrogen and OH. Now when you're learning this, you have to learn it from the basic structure, so it becomes easier for you to identify it. This will become oxygen here. This is hydrogen, OH and a hydrogen, H and OH. Then you have here OH and H, H and CH2OH. You write it correctly, you get 2 marks. Then question number B. What are non-essential amino acids? Name naturally occurring alpha amino acids which is not optically active. So you can write that the alpha amino acids which are needed for health and growth of human beings and are synthesized by human body are called non-essential amino acids. If you want to give an example, you can give glycine as one of the example. Alright. Then C part is which vitamin deficiency causes the disease rickets? It's nothing but vitamin D. Alright, so that is the answer for question number 46. Next, the last question is on polymers. How is Buna-N prepared? Give equation. Very easy one. So here you can write that you have N of CH2 double bond CH single bond CH double bond CH2 plus N of CH2 double bond CH, Cn. Alright, so this is buta 1,3-diene, and this one is acrylonitrile. Alright, this will have to treat with the peroxide, and you will get CH2, CH double bond CH, CH2, CH2, CH, Cn, and here N. Alright, so this is going to be Buna N. Then the B part is first one, which is a partial structure for polythene. For polythene, your partial structure is this with CH2 and then N. Then the second part of this is to write this partial structure of neoprene. You have CH2, C, Cl, double bond CH, CH2. And you continue the chain. That's when you have a polymer. So you have to always continue the chain. Next one is the third one. Last question. Give an example for thermosetting polymer. You can give bakelite. You can also give urea formaldehyde resin. Any one can be given. Alright. So these are the answers to the very recent question paper, which is for the pre-final of second year. I hope this has been helpful for you all. I just want you all to go through all of this, and if there's any other question paper that you would want me to solve it, my email ID is there in the description box. Please send me the question paper through that, and I'll be able to solve and send it to you all. Alright, thank you so much.